Hello everyone, my name is Rui Wang, and we will talk about the multimodal attribute statements analyzed for social media. We can use emoji to express our pleased or angry, just like we can't accurately judge a person's emotion by a few words. But when we input a picture, we will be sure it's positive. This one, if you don't have a picture, you can't tell if the news is true or false. But it turns out there are no such clouds in real life. And then, if you didn't see the picture, you might think he was praising about the beautiful weather. Therefore, the appearance of the picture videos can help us to do the sentiment analysis. So multimodal analysis is meaningful. The text of multimodal attribute sentiment analysis can include four parts. The first one is extracting attribute words mentioned in the text, and the second one is classifying attribute words using image. And the third one is performing sentiments classification for the extracted attribute words. And the last one is translating attribute words correspond to sentiments words. First, we will travel the site from Twitter for statistical analysis, one from 2050, another from 207. And let's take this test from Twitter. It can divide in three parts in UMT models. Single model representation learning involves both the text and the image inputs. BERT is used for the test with CLS and SEP tokens added to each input sentence. For image, rendezed CNN models extract the meaningful feature from deep layers. In the top right corner is a multimodal transform used for MNER. Firstly, a standard transform layer is added to output C obtains from BERT encoder to obtain the textual hidden representation R from each word. To capture bidirectional interaction between text and image, a MMI model is preprocessed to learn word representations with visual perception and visual representation with word perceptions. To fix the models focus on highlighted anti-images, an additional text called ESD is added. This text, part of the mean MNER setup, gives MNER prediction use text-based ESD. The BERT encoded output is processed by another transform layers to create the specific hidden representation. Then passed to CRF layers as ESD and MNER are related. Each ESD label corresponds to a subset of MNER labels. To ensure consistent and predictions, a transition measure is introduced. Specifically, the MNER CRF layers is modified to include anti-sparse if from ESD. The unified transformer structure enables multimodal interactions via the MMI model. Three cross transformers obtain text good by images, image good by text, and intramodal interaction representations. A visual gas dynamically controls the model interactions. Words and visual representations are merged into the final hidden representation H by clumping A and B. H is then processed through a standard CRF layer for sequence labeling. Then we can find out the result. That the result after removing the auxiliaries is greater than the result of some previous research models. And the result of the UMT model with the auxiliary task was greater than the result with the auxiliary task. And the summary is that using a unified transform structure for multimodal information interactions, and processing a text-based analysis ESD model, and then achieving state-of-the-art result on two standard Twitter datasets. But in Twitter datasets, there may be a model imbalance between text and image. If one modality has fewer samples or lower qualities, the UMT model may not be able to fully utilize multimodal information, thereby affecting its performance. That's all.